Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Kabir Nasir Ali. I'm here for demonstration of experiment 6. The title of this experiment is Thevenin / Norton Theorems and Maximum Power Transfer. So the main objectives of this experiment is to experimentally verify Thevenin and Norton theorems and to experimentally verify maximum power transfer for resistive circuits. So we will see how we can use a Multisim to simulate to demonstrate this experiment before we come to the actual experiment. The main apparatus we will use, we have a DC power supply, digital multimeter, carbon resistor, and decade resistor box. As we know, Thevenin theorem states that when we have a two-terminal network, this terminal network can be replaced by a voltage source with the value equal to open circuit voltage across its terminal in series with a single resistor, with the value equal to the equivalent resistance of the network. And also the Norton theorem, a two-terminal network can be replaced by a current source with the value equal to the short circuit current at its terminal in parallel with the resistor, with the value equal to the equivalent resistance of the network. The equivalent resistance of the two-terminal network is equal to the open circuit voltage divided by the short circuit current. Maximum power transfer. In a resistive circuit, a resistive load receives maximum power transfer when the load resistance is equal to the Thevenin equivalent resistance of the circuit, that is RL is equal to RT, R Thevenin. The maximum power can be calculated using the expression P, which is equal to B open circuit square all over 4 R Thevenin, where B Thevenin is the open circuit voltage. So the procedure are given here. The procedures are given here. So we will see how we can simulate this circuit using Multisim as the way we are doing. So let me open my Multisim. So here are my Multisim. But if I can share my screen to this, let me see. So share it. And share my second screen. Okay, so this is my Multisim. So this is my, sorry, this is the circuit I will use. Okay, so as you can see here, Here are the procedure that I will use for the simulation of this circuit. Okay, the first procedure states that connect the circuit as shown in figure 1. This is the circuit shown in figure 1. So we have two sources. The circuit is the same as the circuit we use in experiment 5. We have two sources. We have voltage source, this DC power source. Also, we need another one. We have another one here. Then we have the go to place basis. We choose resistor. Then place it here. Then we can use this resistor by Ctrl V. And then we place another one here. Then we place two resistors here. Use Ctrl R. Also we use another one here. Ctrl R. Then we connect this to this. We also connect this one to this. We connect this to this. Then we connect this to this. So the next thing is we connect this to this. So now the second procedure. So what we forget to place here is the ground. We have to place ground. We have to place our ground. So we connect our ground. So now our circuit is complete. So as you can see here in the circuit given in this figure, we have two sources. So I have to change this source to 5 volt. I have to change this source to 5 volt. I have to change this source to 5 volt. But I will use 6 volt for demonstration. So in your actual procedure, you should use 5 volt. And also this one is required 10 volt. So I will left this one with 12 volt. So in your circuit, make sure that this one is 10 volt. So I will change this to the required value of the resistor, which is 47 kilo ohm, 47K. And also this one is 33K. This one is 1K, while this one is 10K. So this one is 22K, which is our R load. 22K, our R load. So now the second procedure said remove R load from the original circuit and measure the open circuit voltage at BOC. So I will remove this. I will remove this. Remove this and then measure the voltage across this. So I will use voltmeter from place indicator, I will use voltmeter, which is vertical. This is my, then I will place it here, then I will place it here. Then now I connect my voltmeter. So as you can see here, then I will simulate my circuit. So now this is my B open circuit. This is my B open circuit. Then I will record it in the table. In your case, this voltage will not be the same as this one because the value of the voltage here and the value of the voltage here are not the same. So in your case, make sure that this is 10 volt, this is 5 volt. So it will not be the same as this. Then procedure number 3 said, measure the short circuit current I short circuit. This is accomplished by placing an ammeter between point A and point B. In this manner, the ammeter will act as a short circuit. So now, to measure the I short circuit, we should remove this one, this, then we will place ammeter. Go to ammeter, we place ammeter. We place ammeter. This is the ammeter. This is, we connect it here. Then we measure this. So this is our what? I short circuit. This is our what? I short circuit. So we will record it in our table. So now, procedure number 4 said, replace the voltage source with the short circuit. With R load removed from the circuit, measure R Thevenin using the multimeter. So we should remove the voltage source from the circuit. We remove the voltage source from the circuit. We remove the voltage source, then we remove this because it's a place where we have our R load. Then we choose multimeter. Then we connect the multimeter in the place of the R load. Then we set this to the ohm meter. Then we measure our R Thevenin. So this is our R Thevenin. This is what? Our R Thevenin. This is what? Our R Thevenin. So now, in your case, you make sure that you connect your multimeter in correct manner and also measure the R Thevenin. So now, the second thing is record the result in table 2. So you should go there. This is your table 2. You have measured the voltage B Thevenin, which is our B open circuit. I short circuit is our what? The current we measure using the ammeter, and R Thevenin is the last measurement that we carried out. So the next thing is to go to the maximum power transfer procedure. This is what? The maximum power transfer procedure. So what maximum power transfer procedure said? We will see it now. This is what the maximum power transfer procedure. So let's see. Reconnect, the procedure said reconnect the circuit as shown in figure 1. So now we will remove this. We remove this. We put our R load back to its position. We reconnect it. We put our R load back to its position. We connect it. We connect our sources. We connect our sources. We connect our sources. We connect our sources. So now the next thing, our circuit now is reconnected. The next thing is, but now replace the 22 kilo ohm resistor between point A and point B by the variable resistor, which is R load. In this case, the variable resistor, in this case, is the variable resistor. So we are going to vary the value of this resistor from 2.5 kilo ohm to 10.5 kilo ohm instead of 1 kilo ohm, and measure the voltage BL in each case and record it in this table. So in each case, we will measure the voltage and record it here. So what we will do next is to take our voltmeter and connect it here, and connect it here. We connect it here because we want to measure the voltage across here. So we will change the value of this resistor to 2.5 kilo, to 2.5 kilo, and then press OK. Press OK. So now our R load is 2.5. Then we simulate. This is the value of the voltage. So this voltage value, we will record it in this table. We will record it in this table. After we record it here, then we also change the value of this R load to 3.5. To 3.5 kilo. And now our value of the resistor is 3.5 kilo. So we will take this, we will take our voltage and record it here. And record it here. In each case, as we are changing the value of the resistor, at the same time, we are recording the value of the voltage in its corresponding box until we reach 10.5. So now we will change this value to 10.5. 10.5 kilo is our last value of the resistance. So now we simulate. So this is the value we have for the voltage, then we record it here. Then we record it here. Then we record it here. So we record it here as our last value of the voltage as required from the procedure. So the procedure, they said, then record all the values in table 3, which is what we have been done now. Then the next thing is to calculate VL, that is power load and power, from step 7 above and record in table 4. So from here, we have the value of the voltage. Then we will calculate the power. We will calculate the power using the formula we have, that is power is equal to B square over R. Using the formula of the power, B square over R. We calculate the value of the power as B square over R. Then we find the error between the theoretical and the simulation. So this experimental, you change it to simulation in your report sheet. Now questions. When you come to the questions, you are going to draw Thevenin equivalent circuit, Norton equivalent circuit, and also you will plot the value of power against RL, which is you will use the value of the power you get here and the value of the resistance you have here, and you plot. That is the end of this experiment. So see you on Wednesday. Thank you, everyone. Try to simulate it so that when we come to the class, you will have your question and I will answer them, inshallah. Thank you. Thank you, everyone.